In this video, I will further elaborate the formula of finding the distance between a point and a line, and using this formula to find tangents to a circle. Here, I will make use of the examples I have given to you previously. Let's start. The standard way to do this question is to substitute the equation of the straight line x plus y plus 4 equals 0 into the equation of the circle x squared plus y squared plus 2x minus 6y plus k equals 0. Okay, that is from the equation of the straight line y equals negative x minus 4. Okay, put into the equation of the circle. It becomes x squared plus negative x minus 4 squared plus 2x minus 6 times negative x minus 4 plus k equals 0. Okay, expanding, you get x squared plus 8x plus 16 plus 2x plus 6x plus 24 plus k equals 0. Okay, collecting the like terms, x squared plus x squared is 2x squared. And then the term in x, which are 8x, 2x, and 6x. Altogether, it is 16x. And finally, the constant term, which is 16 plus 24 plus k. Okay, which is 40 plus k, equals 0. If the line x plus y plus 4 equals 0 is tangent to the circle x squared plus y squared plus 2x minus 6y plus k equals 0, then this quadratic equation 2x squared plus 16x plus 40 plus k equals 0 has only one repeated root, which means that the corresponding discriminant equals 0, which means 16 squared minus 4 times 2 times 40 plus k equals 0. Okay, we may simplify. 256 minus 320 minus 8k equals 0. So negative 8k equals 320 minus 256, which gives k equals, okay, here is 64, so k is negative 8. Now let's look at the alternative way. First, let me write down the equations for reference. X plus y plus 4 equals 0 is the equation of the straight line, and x squared plus y squared plus 2x minus 6y plus k equals 0 is the equation of the circle. From the equation of the circle, you can easily write down the center, which is negative 1, 3, and the radius, which equals 1 plus 9 minus k, and then square root, okay, 10 minus k square root. You can get this by formula or computing the square. Let me draw the diagram. From tangent perpendicular to radius, the distance between the center and the tangent is just the radius. So by formula, the distance between the center -1, 3 and the straight line x plus y plus 4 equals 0 can be calculated by x plus y plus 4 over the square root of 1 square plus 1 square, positive, negative, with x and y replaced by -1 and 3, which are the x coordinate and the y coordinate of the point. Okay, and this equals the square root of 10 minus k, which is the radius. Simplifying, we get 6 over positive negative square root of 2 equals square root of 10 minus k. Okay, because we just take the positive distance, so we drop the -1 and then square both sides, which becomes 36 over 2 equals 10 minus k. K therefore equals 10 minus 18, which is -8, the same as in the last method. This question is from Hong Kong Certificate of Education, year 2000. Mathematics period 2, question number 49. Again, let's look at the standard way first. Okay, the straight line is y equals mx plus 1, and the circle under consideration is x minus 2 square plus y square equals 1. Okay, if we substitute the line into the equation, that means x minus 2 square plus y becomes mx plus 1, okay, square equals 1. And then once again expanding, x square minus 4x plus 4 plus m square x square plus 2mx plus 1 equals 1. And then collecting like terms, the term in x square is m square plus 1x square. The term in x is 2m minus 4x, and then the constant term, okay, we can cancel out the 1 and only plus 4 left. Okay, the next step again is consider the discriminant, which is set to be 0, which is 2m minus 4 square minus 4 times m square plus 1 times 4 equals 0. Expanding again, we get 4m square minus 16m plus 16, okay, for the first bracket, that is this part. And then for the second bracket, we have minus 16m square minus 16 equals 0. Simplify, you get negative 12m square plus, minus 16m equals 0. Divided by negative 4, you get 3m square plus 4m equals 0. So m equals 0 or negative 4 over 3. Okay, the answer is D. You may try to work out by yourself again and see whether you have any problem. Now let's look at the alternative way. Okay, first, the straight line y equals mx plus 1 and the equation of the circle x minus 2 all square plus y square equals 1. It's quite easy to see that the center of the circle is 2, 0, and the radius is just 1. To find the distance between the center and the tangent, okay, we first write down the equation of the straight line, which you have to be careful because you have to write in the general form mx minus y plus 1, okay, equals 0. Okay, this is the numerator, and the denominator is m square plus 1 square. Of course, it's negative 1 square, but I dropped the negative side because it's square. Okay, equals the radius is just 1. Okay, here once again we replace x and y by the coordinates of the center. That means x becomes 2, okay, times 2, and y becomes 0. Okay, after simplify we get 2m plus 1 equals plus or minus square root m square plus 1. Okay, square both sides, we have 4m square plus 4m plus 1 equals m square plus 1, which we get 3m square plus 4m equals 0. Okay, finally, quite clear that m is 0 or negative 4/3, which are the same as before. Up to now, both methods work quite well, and you are recommended to do both questions by yourself once again to get familiar with them. Now let's look at the third question. In this question, you are told that the straight line L, okay, x minus y plus k equals 0 is tangent to the circle C1. Okay, x squared plus y squared equals 2. And you are asked to find the shortest distance between the line L and another circle C2, which has equation x minus 4 square plus y plus 2 square equals 1. Okay, you may pause for a while and work out by yourself first and check with the way I do. I will do this question in both methods. The first step should be finding the value of k. Okay, by the standard way, we first substitute from the equation x minus y plus k equals 0, we write y equals x plus k and put into the second equation C1. So we'll get x squared plus x plus k squared equals 2. Okay, which get 2x squared plus 2kx plus k squared minus 2 equals 0. Okay, then the discriminant is 2k squared minus 4 times 2 times k squared minus 2 equals 0, which is 4k squared minus 8k squared and then plus 16 equals 0. Okay, we get negative 4k squared equals negative 16, or that means k equals k squared equals 4, or k equals plus minus 2. Because here k should be greater than 0, therefore we reject the negative and k is positive 2. Now the second step, we want to find out the shortest distance between the line L, which is x minus y plus k. Now k is 2, and the circle C2, x minus 4 square plus y plus 2 square equals 1. It's easy to see that the corresponding center is 4, negative 2, and radius is 1. To work out the shortest distance, let's look at the diagram. The x-axis, the origin, and then the line L, okay, with slope 1, and the y-intercept is 2. For the circle C2, the center is 4, negative 2, okay, which is at this point 4, negative 2, and the radius is 1, so the circle C2 is, the graph of C2 is this one. Okay, from the graph we can see that the required shortest distance between the circle C2 and the line L, okay, let's call it D, is the difference between d prime, which is the distance between the center and the line, and r, which is the radius of the circle. D prime is the perpendicular distance from the center to the line L, and to find d prime we have to find the distance between the foot of perpendicular from the center to the line L. Okay, let's call this foot of perpendicular A, B, and use capital letter A to denote it. D prime actually is the distance between the point AB and the point 4, negative 2. So if we can find AB, we can find D prime. AB is the intersecting point of the line L and another line L1, which is perpendicular to L and passing through 4, negative 2, and AB. L1. Okay, L1 is perpendicular to L, and L1 passes through 4, negative 2. Let's find the equation of L1. First, we know that the slope of L is 1, and because L1 is perpendicular to L, therefore we know that the slope of L1 is negative 1 over the slope of L, which is negative 1. And by point slope form, we know that y minus negative 2 equals the slope x minus 4, which means y plus 2 equals negative x plus 4. And therefore L1 is x plus y minus 2 equals 0. Okay, let me copy. L is x minus y plus 2 equals 0. Okay, solving. Okay, add together we have 2x equals 0, or x equals 0. Correspondingly, y equals 2. Okay, therefore the point A equals 0, 2. Now let me copy the circle C2 again, which is x minus 4 square plus y plus 2 square equals 1. And therefore, the center of the circle C2 is 4, negative 2, and the radius is 1. Okay, for the distance between the point A and the center of C2. Okay, we can calculate, which is 4 minus 0 square plus negative 2 minus 2 square, and then taking square roots. This equals 16 plus 16, 32, and then taking square root. So the answer is 4 times square root of 2. And finally, the shortest distance, as said, it's just the difference between the distance between A and the center of C2 and the radius, and therefore the answer is 4 square root 2 minus 1. Okay, that's the answer. You like it? You may try by yourself. Now let's solve the same question using the alternative way. The first step, the same, is to find K. Here, the distance between the line L and the center of the circle C1 is x minus y plus k over the square root of 1 square plus 1 square plus minus equals the radius of C1, which is square root of 2. And the x and y are replaced by the center of C1, which is just 0, 0. So quite clear, k is plus or minus 2, which once again we reject the negative, and k is positive 2. Okay, step 2. We consider this diagram once again. Okay, the y-axis and then the x-axis, the straight line L, okay, with y-intercept 2, and the circle C2. Okay, with center 4, negative 2, and radius 1. The distance between the center 4, negative 2, and the line L can be found by the formula. Okay, let's use the formula. Distance between L and 4, negative 2 equals the numerator is the left hand side of the equation of L, x minus y plus 2, and the denominator is the square root of 1 square plus negative 1 square plus minus. X is replaced by the x coordinate of the center, and y is replaced by the y coordinate of the center. So altogether is 8 over plus minus square root of 2. Okay, we take the positive one, which equals 4 times square root of 2. The required shortest distance between the line L and the circle C2 is just the distance between the center and L, 4 square root 2 minus the radius. Okay, That's what we need to find. Now, which method you prefer? Consider this last question. Given a point 2, 3 and a straight line 12x minus 5y plus 1 equals 0, find the distance between them. First, let's draw the diagram. Okay, this is the line 12x minus 5y plus 1 equals 0, and this is the point 2, 3. The distance between the line and the point is this one. The perpendicular distance between 2, 3 and the foot of perpendicular from 2, 3 to the line 12x minus 5y plus 1 equals 0. Just as before, to find the distance, what we need to do is to find the point here, and which is the intersecting point of the line 12x minus 5y plus 1 equals 0 and the line here. Let's call the original line L and its perpendicular line L prime. The slope of L is negative 12 over negative 5, and the slope of L prime is just negative 1 over the slope of L, which is negative 5 over 12. Okay, and L prime passing through the point 2, 3. Therefore, equation of L prime can be found by y minus 3 equals negative 5 over 12 times x minus 2. Okay, simplifying, 12y minus 36 equals negative 5x plus 10, which is 5x minus, plus 12y minus 46 equals 0. Now we have L as given, 12x minus 5y plus 1 equals 0, and L prime as found, 5x plus 12y minus 46 equals 0. On solving, we multiply L by 5 and L prime by 12, which gives you 60x minus 25y plus 5 equals 0, and 60x plus 144y minus 552 equals 0. The first equation minus the second equation, we get minus 169y plus 557 equals 0. So we get y equals 557 over 169. Okay, using this to find the x, putting y equals 557 over 169 back into equation of L. Okay, 12x minus 5 times 557 over 169 plus 1 equals 0, then you can get x equals 218 over 169. Finally, the required distance equals 218 over 169 minus 2 square plus 557 over 169 minus 3 square and then taking square root. Okay, you will find the answer. Very beautiful. It's just 10 over 13. Okay, the whole thing is not that difficult, but the clumsy fractions will make everything much complicated. Again, I recommend you to try by yourself once. Using the alternative method, all calculations will become very simple. Now, the distance can be calculated by the formula, okay, which is a fraction. The numerator is the left-hand side of the equation of L. Okay, with x replaced by the x coordinate of the point, and y replaced by the y coordinate of the point. And then the denominator is the square root of the coefficient of x. Okay, and then square plus the coefficient of y, and then square. Okay, we only take the positive distance. Okay, now the numerator is 24 minus 15 plus 1, and the denominator is just square root of 169. We can get 10 over 13, okay, easily. Finally, do you remember this question? Try again, and I will tell you the answer in the next video. Thanks for watching. That's the end of this video.